I'm really amazed by all the knowledge we have a possibility to exchange and learn from. And I must say I'm a little bit humbled to be here today because I'm really new in this field. And Roland, he has a view that when you work with something, you need to have your hands into it. So I last year got my hands into hot water treatment of apple fruits. And I will today talk more about what is the impact of using this technology on the fruit quality and also the physiological disorders. How is it affecting the fruits? Because that's the focus we have in our group. So I'll just start out with this one here because the I think very important question is really what is the optimal treatment temperature? How should you do it? Because we have heard already that if you overtreat, you get too much rot. If you undertreat, you also get too much rot. So it's really about finding the right way to do it. And last year we did some experiments, and I must say we found these results. We can confirm the results we have already seen because we saw that this is apples treated with different temperatures for 3 minutes. When the apples were untreated, that's the level of rots, percentage rots. It's 2 cultivars we had here, the average of. And then when we treated with 20 degrees, 50 degrees, 52, 54, 56. And you can see that around 50 degrees we have less rot than if we don't use, if we don't treat the apples. And if we increase the temperature, we have more rots. So how do we know what is the right treatment? And that's what I'll come into. And why did we have more rots when we increased the temperature? It's also what Roland said. We had more physiological disorders. You can see it by this bars here, more physiological disorders. And when we had more physiological disorders, we also had this Penicillium expansum. And we show very nicely what you have already shown. The next question is, how does this hot water treatment affect fruit quality? I'm very interested in that because if it's unedible fruits and they're not good, I think we shouldn't use the technology. That's what life is about. It's the pleasure of food. So, of course, we did analyze the fruit quality. How is the firmness? And this is the results from the studies of firmness over the storage season, and there's a little tendency to increase firmness if we increase the temperature, but again not significant difference. Then when we come to soluble solids content, there's absolutely no differences between our treatment. So that's what's mainly done in the literature, I think, regarding quality. It's those measurements that has been used. So we had to think, what can we do to know more about how the treatment is affecting our fruits at the time we are treating them? Because if we have to wait a long time, it's not interesting anymore. Then we have maybe overtreated the fruits or we have undertreated the fruits. So this is our experimental design. We had 2 cultivars, 3 minutes, these different temperatures. Then we dried the fruits after the treatment to get all the excess water away from the fruit. And then we stored them at 2 degrees at 14 weeks. And we had different setup, but I'm just showing the results from normal dipping of the fruits into water bath. And the new thing we looked into is how is actually the treatment affecting the temperature of the tissue. So we used a camera that's used in the houses to find cold kuldebroer, where you have no good insulations. You use these cameras and you can measure what is the temperature. So we use this camera, very simple but actually very effective. And also what you can see here is we sample the volatiles that the treated apples are releasing when we have treated them. And that's what I'm going to focus on now. First of all, this is from our measurement of the fruit temperature. And these are apples treated 3 minutes, different temperatures. You can absolutely see no difference. These are the pictures with our camera. And what you can see here, when we dip the apples 3 minutes in 20 degrees, we have the same temperature distributed in the fruit. When we increase the temperature in the water, we have a gradient. So the apple is still cold inside and it's warmer towards the outside. And this is showing approximately the temperature. So the more yellow, the warmer. And that's natural because the apple has just been in the hot water. And here at 54 degrees, again, we have this gradient. I don't have pictures with me, but what we saw was after about 25 minutes, this was equalized. So there was no more difference between the temperature in the inside and the outside after 25 minutes in this cabinet where we ventilated with air. Then we look to this is a histogram, and you can see here how is the distribution of the different temperatures inside the fruit. And of course, when we use the hot water, there was more pixels in the picture that had the high temperature. And when we look to the temperature, you can see here the minimum temperature we measured, that's inside the fruit, near the core of the fruit. It was a little bit higher the more heat we applied. And the maximum temperature, that's the outside of the fruit, at the skin side. You can also see there was a higher temperature, the hotter, the warmer the water was. What you also can see here is the maximum is here 33 degrees, and we treated with 54 degrees hot water. And it's because it's really very difficult to measure temperature. Because once you take the fruit up, just from taking them up from the water bath and cutting the fruit and measuring, it will already lose, the temperature will go down. So that's something we have to work a little bit more with if we can get better measurements. But again, for comparison, we are quite satisfied with it for this first year. And this is showing the average temperature of the fruit. And the average temperature of the fruit is of course dependent on the size of the fruit, but as we treated fruits that were 20 degrees at the time of treatment, it does not influence as much as if you treat cold fruits. We will have a much bigger impact of size. Now, when we come to physiological disorders, that was really our interest. When are we getting the physiological disorders? Okay, I will say we have to wait 14 weeks. Or about 8 weeks we could start to see something, and it's really long time to wait. So we wanted to know this earlier. And you can't see anything when you treat. It's impossible. You can't see it. So, because we wanted to know if there's physiological disorders, because it's a sign of some stressed tissue. So it's very important that we don't stress the tissue too much. A little bit stress is good, but not too much. And what happens inside the apple when we stress it? I would say the same as with us. When we are very calm, we have our pulse is very on the same level. The pulse of the apple, the respiration rate is also at the same level, and the ethylene production rate, it's very flat, not much variation. This is over time at constant temperature. But if we stress it, the tissue will react, the respiration rate will go up and go down again. So it's a transitional increase in respiration rate and also an ethylene production rate. And that's, we know that the apple tissue is reacting by sending us some gas signals. That's very good, because then we can use these gas signals and try to understand them more. We also know that the the stress level, how much stress we apply, it depends on the severity, I mean the temperature, in this case with hot water treatment, duration, how long time, and how many times do we do it. But what is also important, it is the genotype, which cultivar are we talking about? It's also important how is the maturity, the pre-harvest history, how was it treated in the orchard, but also how did we treat it after harvest. That is also very important for the reaction of the tissues from these treatments. So, and that's really the challenging part. How can we know what is the optimal treatment to get this immunoreaction in the fruit? Yeah. So what did we do? We actually decided we would work more with these volatiles. We decided we wanted to know more about these signal components. It's like us. We are also giving signal components all the time. I mean, an apple is not much different. We have different smells from our body. The same with the apple will have different odors released. Some of them can have a very pleasant odor. We have heard that. But we also know from the talking with Roland that some of them do not have a very pleasant odor. And I don't know if you tried to smell some of these.
I can still smell them sitting here. I think especially on that penicillin one, it would be very helpful, Roland, because it's quite naughty.
The penicillium one. That's of course the one to which I'm putting the data on.
Yeah.
It's the most promising sequence.
Yeah. It's actually, it's interesting. We are working with penicillium in another project on vegetables. It's exactly the same story. Penicillium is an excellent organism. And I'm so happy to find out that, you know, we can work on penicillium on apples, we can work it on vegetables. So we can get to know much more about penicillium and what compounds are released from penicillium. Because then we can know something about the senescence stages and the rotting of the apples or the vegetables by monitoring the penicillium. That's the idea. Okay, back to gas sampling. So what we do, we have some big jars. We put apples in the jars after they have been treated. We take a gas sample. It's Martin here taking lots and lots of gas samples into some vials, 3 milliliter vials, and then we just put them in the freezer. It's very simple, I think. Isn't it, Martin? I think.
I mean, the freezer is what's simple.
I think it's really simple. Once you have the techniques, it's simple. Everything is simple. Okay, the most worksome part is really the GC-MS analysis. You can handle a lot of samples in our GC. You can produce masses and masses of data, but understand what you have in your data. That can take months and months. So I would say all this is nothing compared to what's going on the machine here and get the data out of it. Because we get a lot of data. I mean, in a gas sample, just a simple one, we could get 15, 20 different peaks, and then when you add it up to all the samples we take, it's a lot. So this is just some of our first results coming up from the hot water treatment. We have here Pinova treated at 20 degrees and treated at 56 degrees. And this has physiological disorders. We knew that, and when we compare the chromatograms, this is a chromatogram where you can see the retention time. It means when the different volatiles are coming out from the GC. When we look at the retention times, and we take the different cultivars, so this is Inge Marie treated with 56 degrees. This is Pinova treated with 56 degrees water, and this is 20 degrees. So here you can see the content of acetaldehyde in our gas sample, and this is just taken 2 hours after treatment. or something like that. We measured over different days the same samples. And there's an increase in acetaldehyde. And that's showing that you have anaerobic metabolism. It means lack of oxygen. So the treatment is affecting the amount of oxygen that can penetrate into the intercellular spaces inside the tissue. And I think this is, and methanol is the same. But you can see here the difference between the cultivars. This is showing some of the esters that are characteristic for apple fruits. And what you can see here is once you treat with a high temperature, you have less production of the esters than if you treat with a low temperature. So you apparently affect the volatile metabolism, the ester production. And I think that's quite interesting to sort of, we have different, from the compounds we see here, we can go and look at different parts of metabolism inside, know something about the apple. This is showing methanol with the different treatment temperatures. It seems like there's an increase in methanol the higher the temperature. This is showing the content of dimethyl sulfide. That's a sulfur compound, probably from degradation of the free amino acids with sulfur in. Again, but here there's not much difference in the lower level, but it could be that right now we are looking for markers that we could use to sort of to find out which is the optimum temperature. Yeah. I was very far. Water treatment of what's going on signal compounds, signaling inside the tissue. And what it's showing, this was actually developed in United States by Sulfide, and it was about wounding, when you wound a tissue. But every stress, every abiotic stress you do to the tissue, you will have some reaction inside the tissue. And I believe from what we have seen and our knowledge about tissue, living tissue, that this will be going on with different abiotic stress. But at this moment, we can measure the respiration rate. We know it increases when we treat with higher temperature. Of course it increases because it becomes warmer. And when it becomes warmer, the enzymic activity is higher. But there could also be, apart from that, an effect on the stress you apply to the tissue. But we can only have it as a total measurement. We also know that the ethylene concentration is increasing from applying the heat. And of course the ethylene level depends on what stage your fruit is in, whether it's how mature it is, the ripening stage of the fruit. But again, these two general measurements is just showing that there's an impact of what you do on the tissue. We also know from our last year's studies that we have an impact on the volatile metabolism, because we can see different volatiles that are up and down regulated from the treatment, and that's why we really want, and that's where our focus is, to work on the volatiles, because they tell us much more than what respiration and ethylene production rate tells us. And then we are also looking into the phenolic metabolism, especially the up-regulating, down-regulating, the profiles of the phenolics. At the moment we are sampling treated tissue, and we are in the process of analyzing what are the contents in the apples over time and from the different treatments. So physiological disorders are all in this area where we have an upregulation of phenolic compounds, and we have some oxygen where we have this enzymatic browning. So, not least, The team in Oslo, I want to thank them, especially Renata and Martin, for making these very nice results from the presentation, and the rest of the team in Oslo providing very good results in this project. Of course, all the funding body, and not least, last but least, Roland, for your challenging us here in Oslo. It's very valuable. You ask a lot of questions and you make us think. So that is very, very important. And I really hope that you'll never forget to do that, because it's very important for the development of science. So thank you very much.